Very good morning to all of you. Today we are going to discuss linear algebra in a wider aspect, how it is going to be useful in the domain of machine learning. And it is the most important area of mathematics, and it is heavily used or extensively used in defining and manipulating the data in the form of matrices and vectors. Any realistic data, if you take CSV data set or any Excel data set or any kind of data sets in the real world scenario, they are to be represented in the form of matrices. So it has rows and columns, we use it to say in terms of matrices. But in terms of data set, when we look at it, we are going to represent them in terms of rows and columns. The columns are nothing but the attribute values we are going to have. So if you know the matrices, if you know the data set and how to represent data set into the form of matrices, then you can manipulate based on various operations of linear algebra. So the subtopics of linear algebra we are going to discuss are matrix algebra, eigenvalues and eigenvectors, singular value decomposition, vector spaces and subspaces, linear transformations, and norms and inner products. So these are the various topics we are going to discuss today in our continuation. So the basic operations of matrices are nothing but addition, subtraction, multiplication, and inversion, which are shown here, which are very, very preliminary level. Any student can be able to understand these kind of operations of matrices. So here I have shown all the four types of operations of matrices. Eigenvalues and eigenvectors. So these are very, very important in the terms of machine learning algorithms for dimensionality reduction aspect. So there are two methods we use: principal component analysis, PCA, popularly known as, and LDA, linear discriminant analysis techniques. These two are used for dimensionality or dimensionality reduction of the data set, because a huge data set consists of many number of attributes which are not useful in the analysis. So only few of them are useful. So in order to reduce those dimensions, we are going to use these eigenvalues and eigenvectors for PCA as well as LDA. And coming to the singular value decomposition, it's a powerful matrix factorization techniques, and it is used in variety of machine learning tasks such as data compression. So that means data compression means in terms of attributes, in terms of rows also, and dimensionality reduction in terms of attributes and feature extractions. So which attributes are more useful for our machine learning analysis. So this is how we are going ahead with the singular value decomposition. And the another topic we are going to discuss is vector spaces and subspaces. ML models often operate in high dimensional vector spaces. So a solid understanding of vector spaces and subspaces is necessary to effectively manipulate and analyze the data. So most of the realistic data sets, if we are looking at, they are in high dimensional nature. So these subtopics can be very, very useful in analysis of the realistic data. And the another topic we are going to discuss is linear transformations. Transformation means we are changing one form to another form. So the data between different coordinate systems and commonly used in computer graphics and image processing. So we can move from 3D to 2D in a computer graphics, heavily used the linear algebra, as well as in image processing. So norms and inner products, these are used to measure magnitude and distance between vectors, and are used in variety machine learning algorithms like support vector machines. So the distance between two support vectors, if you want to measure, and the hyperplanes, the distance between the hyperplanes also, we can make use of norms and inner products. This is how the subtopics of matrix algebra, linear algebra we are going to use Under that, the subtopics are matrix algebra, eigenvalues and eigenvectors, singular value decomposition, popularly known as SVDs, so vector spaces and subspaces, linear transformations, and norms and inner products. So these are very, very useful and important for manipulating the data sets using machine learning algorithms. So with this, I would like to say thanks to all of you. If you have any doubts, please comment in the given below link and please do subscribe. Thank you one and all. Thank you.